Hello YouTube, in this tutorial we're gonna learn how to grab all elements of array if we don't know how many of them we actually have. Like we have 1000 elements, like integers in this array, so it's tedious to count, so let's do that dynamically. And for some reason I was putting in last tutorial 15 here, so that was probably typing error, and actual number was 5, but that's right now not that important. So every time when you construct that array with unknown number of elements, just don't put anything between these brackets. Right, so now we have our starting like situation here. So this is the thing, and this is for actual documentation. So to grab that dynamic number, we need to use size of operator. Okay, so size of, that's the new thing, and the task of that thing is to query the size of the object or type, in this case array. So it will be used when actual size of the object must be known. So this is excellent for our situation. Now this thing will spit specific result, and that result will be of size t, which is, check this out, alias of one of the fundamental unsigned integer types. Now unsigned basically means positive numbers, and when you have signed integers, that means negative, 0 and positive numbers. So that's maybe something you will run into examples on internet. So it is a type able to represent the size of any object in bytes. So size t is the type returned by the size of operator. Okay, so it is returned by operator and is widely used in the standard library to represent sizes and counts. Right, so this is kind of theory. Yeah, let's get out from here. So first thing, let's grab the size of it by stating that return type. So size t, see, and we have C++ color here, so this is part of C++. So n will be the container for that thing. So how to get this? Well, this will be classical division, because if we look about size, we will look about size of all these things together, and this will be one part of the division, and then we will divide it with the size of one element, and that is how we are going to get the actual number of elements. So it's basically like this. So let's say that the size of these things are like 10 bytes, megabytes, terabytes, I don't know, it's not important. So the size of any of these individually is 2. So we need to multiply that thing with the 5 to get 10. So this is actually the size of these things. So this 10 represents, like theoretically, for simplicity reasons, the size of everything, and the size of every of these individually is 2. So that must be, it must be that 5 is actual number that we need to multiply with individual size to get the biggest size, the total amount. Right, so let's do that using size of operator. So size of, see, so different color than our custom text. So what are we grabbing? Well, numbers. We are grabbing numbers, and we need to divide that thing with the size of individual thing at position 0. So size of numbers is our target, specifically position 0. So let me check that. Okay, I think I am good. And now we can continue with our for loop, but let me just run this stuff. I need to make sure that everything is fine. Okay, so no result, but also no errors, so that's cool. Right, so for loop, and now we need to use the same data type here, size t, and what is our starting point? Well, x, let's say x, and let's allocate 0 to it. Starting point 0, okay, position 0, right? So this is for indexes. Now, those indexes must always be less than this big number. So this number is a top level. If you remember what we have done in the last tutorial, so you have a starting point, you have ending point, and then you have algorithm. So in this case, this is a starting point, ending point is this actual number from reality, and now we need an algorithm. So how to jump from one of these ends to another? Well, not ends, sorry, x's. Yeah, I need to type that here. So we will use increment operator here. X++, basically increment the future one with existing one. So that's like we was using x equals x plus 1. So this is that in that sense, okay? So the next one we're gonna grab it when we add existing one plus that same thing, plus 1 basically, because we are starting counting from 0. Right, so let's go to actual operation. So cout and element at position, and now we need to grab that x, and now we need to have kind of separator between the results, because we don't want to concatenate indexes and actual values. And now we need to grab those things like numbers at specific position, and position will be that specific index. So this is grabbing indexes, and this is grabbing actual value by indexes, by position. So let me test this stuff, and let's run it, and let me check for 0 to 4, 45. Yeah, that's cool, that's cool. Okay, so this works. Now here's a question: what's gonna happen if, let's say, we change this size t into integer? Will that work? Well, let's test that. Integer, will that work? And there you go, so that will work. But a lot of people use the same things, size t up here and down there. Now another thing, can we substitute this size t, which is alias, with actual integer? Well, let's test that. Will that work? That will work, but uses size t. Okay, for this kind of stuff, dynamic ones use size t. So what else is interesting here? Oh, so yeah, let me show something to you. Now see, x++, if we change this to our normal stuff like equals x plus 1, the result will be also accurate. But this is what I was typing in original, like this. This was also accurate way. So prefer this way when you're grabbing stuff from array, if you don't know exact numbers of elements there. And of course you're totally free to go and use 15 minutes or something to learn more about these things that are at your disposal. So size t, size of, and that unsigned, signed thing. So basically every time when you see unsigned, that means data type positive one from 0 to plus, and when you see signed, I have error here, unsigned. Okay, so see the C++ color from editor. So every time when you see signed, that means negative numbers and positive numbers. So it's like group of possible elements. So you cannot force negative stuff in an array that you have defined with unsigned in front of it. But yeah, that's something you're gonna learn over time with a lot of errors in between. But don't torture yourself with these things. Just breathe, and practice a couple of times this stuff. And yeah, let's actually change this to characters. Like, what's gonna happen if you substitute these with I don't know, a and C and D. So dynamic extraction of numbers, will that work? Oh, let's test that. There you go, that will also work. So yeah, I'm gonna shut up. 10 minutes tutorial, longer than I thought, but what you gonna do. Thank you for watching, and as always, see you next one.